Okay, well, welcome everybody. There's still some people coming in, but we'll help them catch up if they need to. So I want to thank everybody for coming. We're really excited today to have I think most of probably all of you know Sam from College of Central Florida, and today he's going to do an overview of teaching PLCs. So it's going to cover everything you need to know to teach PLCs in an hour, everything you can talk about in an hour, I guess. And honestly, this webinar is kind of teeing up another more detailed opportunity to learn more about PLCs. I don't want to put Marilyn on the spot. If she wants to talk a little bit more about a grant-funded opportunity, we could talk about it now or maybe towards the end. Yeah, we'll give Marilyn.
Let's do it a little bit later and let Sam go ahead and get started here. Good morning,
Okay,
everyone.
good. Yeah, thanks, Marilyn. All right, so just real quick, we'll do a quick overview of FLATE. FLATE, the advanced FLATE is the Florida Advanced Technology Education Center, and this is our team. We've got a small, mighty team. We cover the entire state, and hopefully we've been able to help each one of you over the years, and we will continue to do that as time moves forward. So FLATE's vision is to drive Florida's world-class manufacturing, workforce, education, and training. And we'll talk about a few ways that we do that. This is some new information. For those of you that don't have it, this is a really nice, it's a nice report. This came out from the Florida Commerce on Florida's manufacturing. And I pulled out 4 of these facts, and maybe Teresa's going to make our slides available to you. But this is one, if you're doing any kind of presentation with parents or teachers or just the community, you can kind of use this as an icebreaker. So before Marilyn and I used this recently, and before we brought this slide up, we would ask a couple of questions about, what is the number one industry for gross domestic product? Most people would say tourism, right, or agriculture. Well, the reality is it is manufacturing, right? And that's, I think for a lot of people, that's big news or new news. Florida has grown from 2014, about 43 billion impact to 73 billion in 2022, which is a 67% increase. The rate of growth has significantly outpaced all other leading manufacturing states. So we are not only growing, we are growing much faster than other established manufacturing states. And as far as the workforce goes, there's about 423,000 people working in manufacturing as of September of last year, passing both Georgia and New York. So Florida is now at the top 10 in the country for manufacturing employment. I mean, for a lot of people, that's big news. And then the last one is manufacturing employment has grown by 23% since 2014, higher than other leading manufacturing states. So not only are we have an established manufacturing industry, but it's growing at a much faster pace than other states. So that's a good slide. Yeah.
I was just going to suggest that this is good information to when you guys get the slides to use at your advisory committee meetings, to help your local boards put in perspective for the whole state. So you might want to grab this slide for an intro for those meetings.
Yeah, also, it's nice, Ernie, if we could get a poster made of that, because when I put that up in the building, people take notice walking in and out of the building. And so I get a lot of people flowing in and out. I wouldn't mind having like a little, I might even be able to make a poster, but I want it done however you guys want it, because I don't want to mess up any trademarks.
Yeah, all right, that's something. Yeah, I know we've got Teresa loaded up right now, but once some of her projects clear a little bit, we can maybe add this to it and see if we can't create something for everybody. And of course the report, a link to the report's at the bottom of that slide as well. There's some really good information in there. All right, so the things that FLATE does and does well is we help schools with curriculum reform and development, which there's a few projects now that we're going to talk about at the upcoming ET Forum, April 4th and 5th. That's being hosted by Sam at at his college. Thank you, Sam.
State College of Florida. Good morning.
State College of Florida is April 4th and 5th. So we do curriculum reform and development. We also help with student pipeline development and professional development, which we're doing today. So as far as student pipeline development, we certainly go across the entire state promoting manufacturing education. We do a lot of events, support a lot of events, and advertise a lot of events for Manufacturing Day or month, which we really do all year at this point. We have a manufacturing dashboard that Danelli and I just spoke with the developers this morning about some updates. So if you haven't seen the dashboard, please check it out. We host Manufacturing Educator Awards. Let me stop here for a minute because these are so important. And I know everyone's busy, but if you would just, I know all of you work with some industry people, you work with, you work with other schools or just individuals. If you know someone that you think is doing a great job, who's a champion for education and certainly manufacturing, please take a few minutes and go to the FLATE website. It literally would take you 5 minutes to put the information in that you need to put in to get the process started. You're not creating the entire background of the award. You're just putting in some very basic information, and then we'll work with the people that you designate. We'll work with them individually. But please, if all of you would just take a few minutes and post up an award or submit one for somebody you know, that would be it'd be great, not just for that person, but for the entire community. We also publish a monthly newsletter that I'm sure all of you get that is created by Teresa with input from a lot of people, but Teresa puts it all together and does a great job for that. So thanks, Teresa, on that. And we do STEM summer camps. So we're talking about doing one this summer at HCC with Shirley. So we're kind of fine tuning that, and we'll get the word out on that pretty soon. And we also develop and disseminate resources for recruiting girls. All right, next slide. Okay. Okay, so yeah, we talked about the forum, the engineering, the ET forum. We do, a lot of demonstration projects. We're working on creating demonstration projects. We do a lot of educator workshops. One that we'll talk about that sort of would be the next step for you if you want to learn more about PLCs. We'll talk about that towards the end of this presentation. Also we've got Maryland has some grant money that we can use for conference attendee and some, conference attendance for faculty, online webinars, which we're doing today, and program mentoring. All right, so I'm going to hand it over to Sam. All right, great, Sam. Looking forward to your presentation on PLCs.
All right, let's see if I can do this right here. Looks a little different from when I'm going. There we go. All right, I'm going to go ahead and get started. I'm going to make a couple of, come on. Pop on up here. It's not wanting to start. Hold on a second. Let me get my mouse working here. I got too close. Hang on a second here. Let me see if I can just do it from up here.
Oh. I'll add it to the chat again for people who just joined. You'll have access to the presentation.
Yeah. All right. Let's see if I can get it now. Wow. Boy, it's sure moving slow. All right. Okay. So my disclaimer is this is how Sam tackles this subject. It's not meant to be, this is the way you need to be teaching it. This is just one way of teaching it. We all have different ways. So I don't want to make too much. I only have a few slides because I want to do some demos on what I do in my courses. So first I want to talk about, if you're teaching a PLC course, I want to discuss a little bit about prereqs. A lot of you, and I know HCC was one of the folks that has no prereqs for some of their stuff that may be more advanced courses that you realize, before you can start wiring a PLC, it's nice to know if you have electricity training on it. And that could have changed after Alex left, I'm not sure. But when I first come to CF, I went in my first class, I had a second level PLC course, and I had a guy come into the second level PLC course. I said, wow, you already took the first PLC? He goes, no, this is my first class ever at the college. I'm like, there's no way. You don't even know the first thing about PLC. I'm doing advanced stuff in here. And he's going like, what? I said, this is what my advisor told me. And I went back and looked, and there was no prereqs for anything. So all I'm going to tell you is you set it up the way you feel comfortable setting it up. But for me, if they don't have survey of electronics completed, which is my course in basic AC/DC, I won't even let them in the class, and it's listed as that. Also, the same thing for motors and controls. It's listed as a prereq. Electronics, survey of electronics is listed as a prereq for motors and controls. And then, during motor controls, I made it a correc with the PLC. So you either have to take it before or with the PLC. And the only reason I'm doing that is the way I have it set up is I go over relay ladder logic in both courses, basic wiring of control circuits, because I'm wiring in switches, push buttons, relays, and such into a PLC, sensors and everything. I do both of that in both courses. And then controlling outputs. If you're controlling an output through a motor starter or something like that, they need to know how to wire a motor starter because they may have to wire all this stuff up. So what I've done is I teach them as a pair of classes, and they overlap. And I'll show you as we go through that some of the stuff I do in PLC is also in motors and controls. So when they do it in the PLC or in the motor control class, they just submit it in the PLC class. So I'm only grading one thing at a time. Then I just transfer the grade over. So where do you start with PLCs? Well, my first week, basically, I go over the history of PLC. I talk about being an old relay technician because that's what I was when I first started, and how there were walls with relays on both sides of them, just big rat's nest of relays up there wiring everywhere. And hopefully, cross your fingers, they marked which relay goes with which control circuit, so you don't have to go try to figure it out. And GM sent out a proposal to different groups of people, and someone picked it up, one of the professors, and he created, actually it was gosh, I'm trying to think of the name. Motorola is a R&D person from Motorola that actually started designing a PLC to work with General Motors to reduce the relay issues that they were having. And the first one was called ModCon, and that was modular controller. That's what it was designed to be. So I go over all the history of how GM started using it in the 60s and 70s, and found out that in the old days it took you 2 or 3 hours to troubleshoot and repair a motor, where you did in a couple of minutes now. And it just went, when they did it, everybody else fell in line, and that's what it is. And then I kind of go over how they work in the second week, maybe first week a little bit. At one time, they were called industrial computers, believe it or not. They weren't called PLCs. They were programmable logic controllers. They were actually called industrial computers because why? They had the same architecture as a computer. They had memory, CPUs, inputs, outputs. They're programmable. You could do anything you want with them. And bottom line, it's almost like working with a computer because you could add more memory to them if you needed to, if you bought a different module. And you had, modules you could add to them if they were modular versus fixed. And we went over what's the difference between a fixed PLC and a modular PLC. And for those who don't, a fixed PLC has the power supply inputs, everything in one box. Where modular, you add all that. You have a rack, and then you add the power supply. The first slot's always your CPU, and then you can add all the inputs and outputs you want. So I go over how all that works together and fits, and how it all works together. The next following session I do is the numbering system. And you're going, the numbering system? Why that? And I'm going to tell you now, if you've never been with a student who hasn't seen hexadecimal, octal, binary, and they put in a decimal value and send it out, and they see these numbers and letters, and they're going like, what the heck is this? They have no idea what a hexadecimal is, and they're going like, oh, I brought that in, and it's all a bunch of numbers and letters underneath, but I see the number. And they're like, well, that's because most PLCs are hexadecimal values when they use it, 16, bit type things. 0 to 15, so to speak. Decimal is base 10, binary, which is the center of the universe for the computer world, is base 2. And then most of you may not know it, but if you go to Mitsubishi or Automation Direct, who uses the same Koyo type products in programming, those are all octal. And you'd be surprised what they're using in those. It's not hexadecimal. So we teach them how these number systems work and then how to convert between them. So if they're sending out something or information or receiving it and they see it in a certain format, what does that really mean? And then they can convert it to something they can understand, like a decimal, something along those lines. So they need to understand how the numbering system works in computers. And I will do binary coded decimal, but I'm going to tell you, I'm going to show you when I put that in, because I don't do it right up front. I say, and there's also binary coded decimal, and we're going to talk about that at the end of this first semester into the beginning of the second semester. And that's kind of how I do that one. And then again, I had a professor one time that worked for me, and he used to tell the students, and I always laughed when I heard this, but he goes, if you want to learn how to program like a PLC, you got to learn to think like a PLC. And all he's saying is you need to understand logic, like hex, not, and, in, or, XOR, in, XOR, those segments. And if you don't understand what those are, you can't really understand how to put inputs in front of an output that's going to generate a signal that you need to turn that on. And I try to teach my students, look from the back forward. I'm trying to turn this on. What do I need to turn this on? And that's how we're going to make it work. And then you think that's fun. I get into Boolean algebra, truth tables, and you're saying, what in the world are you doing, Sam? Well, I don't necessarily make them do a lot of problems with Boolean algebra, but I show them what it is. I show them what a truth table is, and I show them the logic gates from the back. And I tell them, I said, you're going to have some electrical engineer who has no idea what a PLC is, who's trying to build a program that he doesn't understand how it works. And he's going to hand you either a Boolean algebra thing, a truth table, or some logic gates and say, make this work. And you're going to go, what the heck is this? Because he has no idea what you do. And the normal technician, not an ET technician, would not understand what he's talking about. So therefore I tell my students, you have to be that liaison and understand what logic is, what Boolean algebra means, what the truth tables, and also you need to be at the tech level doing relay ladder logic and basic relay logic. This would be another week of just training on this stuff and trying to get it. And one of the ways I do it, to be honest with you, is called the constructor software. The highlighted CHM software is a link. I don't know if it transfers into the PDF or not, but any of you who want the links can contact me, and I will provide you with the links. I actually have the websites up that I'm going to show you here at the end when I do demo. But this helps develop relay ladder logic diagram. It actually simulates it working. So where I get this from is I make them purchase the software through the bookstore with their monies from their financial aid, or if their company's paying, whatever. And then we sit down and learn to develop the relay ladder in the motors and controls. And guess what? I also use it in the first PLC class at the same time. Therefore, there's huge overlap here. The basic relay ladder, they have to develop like a push button to turn on a light, or maybe a start stop, or a wiring diagram for a motor start stop circuit, is actually in both courses. So when they do it once, they've completed 2 assignments, is basically the way I've done it. And then I can go in and look and grade one of them and immediately go over and just put their grades in for the second one, because I already know what they've done. They've submitted it twice. It cuts down on me having to go through and go in detail through their things 2 or 3 times. So makes it a lot faster for me to teach that way. And technically I would be reviewing it anyway if I were in the PLC. So I just went ahead and made it both, and that's why I teach them simultaneously. That's the way I do that. Then, after I've completed that and got a basic relay diagram up, I start going into wiring on a PLC. At the same time, in the motors and controls, we're actually starting to wire basic circuits like, a 2-wire circuit, or maybe starting to get into 3-wire control circuits and automated handoff and all that. And I think the first one I do is in the motors and controls is a manual starter for a motor. I've already taught them how to wire the motor by this time and how to do all that. And then on the PLC side, I'll pull up a diagram, which I will show you my stuff when I get done, of an input card. It's a picture of an input card with a plus on top of it or a minus on top, and also an output card. And what I do is I make them draw in the sync wiring to a input card. And I teach the sync source. And I actually draw a picture of a sink with a tub under, a faucet with a sink underneath and dishes in the thing. It's a complicated lecture, I can tell you. But I talk about, the faucet being the source coming from the reservoir. It's being on pumps or maybe towers that are providing the pressure. And then the load is the sink of dishes. That's the load you're having to do. And then I have to complete the circuit back. So remember, in electrical, they've learned you have to have 3 things to make a circuit work: a source, a path, and a load. And I show them, well, here's my source, and then here's my path. My water flows into the sink, and then from the sink, it flows back to eventually the reservoir. It might go to a treatment plant, back into a water source and back through the pumps. So you're making that complete path. And the load is your dishes. So you have a source, a path, and a load, just like you would anywhere. So I'm bringing power in, and your input is the sink. It's bringing in the power, and then it's sending it back to the source. But guess what? An input could be a source. It could be that I'm sending power out to something, and it's taking it back. And then, of course, we go over what does analog card look like, and what does that mean? And then I have a few other configurations like high-speed counters, RFID, and scanning and all that. And I show them what those are, but we don't get hot and heavy into it. I just kind of show it what they are, and that there's different ways you're going to wire these. And we'll get to those in the second PLC, because that's when I really go into that. Output card, same way. I show them how to do the source wiring, where the faucet's the source now. And then we go into, it can be a sink, just depends. So when you're buying cards and setting up a configuration, maybe you have a PLC that's out there and you got to replace the cards. You want to make sure you don't put a sink in for a source or a source in for a sink. You want to try to keep it identical, because the numbers change and everything, and you end up having to reconfigure all your IO if you don't put the exact same thing in. And then, of course, we do a lot of labeling, and I show them what I/:1/0 means. So we do go over the labeling on the PLC. And again, analog and some other output configurations that we may use. And basically, after that, that's when we get in. Now, I'm literally 4 weeks to 5 weeks in before they even start the programming. I mean, I had to give them all this basic information just to get them up to getting ready to program. And one of the software packages I use is the Logix Pro software, which again, I put a link in here and hopefully it passed through to the PDF. But basically what I do is I go in and teach them how to push a button and turn a light on. And I'm going to show you one other where we actually do that using what we call Easy Veep. Not everybody's going to do that one for sure, because the module you need for it is about $800 to $1,000. And I have several of them because I bought them over 10 years, But I provide the stop start, show them how they can do a start stop in a PLC versus wiring it on the floor, which they're already into by now. They've already wired them up. And then we actually start using real labs using the Allen Bradley micro light, which is a free download. And I'm going to show you where that is. using a 1100 or 1000. Now, a lot of you already know 1000 is no longer being offered. So I put the picture up here of the 1100. It is inexpensive if you're on the toolkit. And we'll talk about that in the Rockwell software as well. And the thing I want you to notice on this slide is right here on the side, go back, sorry, right here, geez, man. Right here on the slide is the serial port connection for that. A Micrologix 1000, that's all they have is a 9-pin serial port. It uses the exact same cables and has the exact same serial port as a 1000. The difference is these now have Ethernet ports. So I can do Ethernet. It has 2 of them in case you want to connect multiple things up. Generally, what I do is I take an Ethernet cable, plug it into a switch, and then I add everything through the switch. I don't really use the secondary one here, but if I want to communicate with this PLC, I could do it with another Ethernet to this one and be able to communicate that way. And I don't even get into that until the second level course, but I'm just showing you if you're going to purchase anything, this is one for teaching the 500 language right here. And then I use the Micrologix Lite because it'll work on 1100 and it'll work on the 1000. And then I have labs and descriptions of the circuit. So this is how I do my labs. I give them a description of what I want done. Then I show them the relay ladder logic. Now you're going to say, why don't you have them develop it? Well, I do. What they do is the beginning labs, they have the relay ladder in front of them, and I make them redo it in Constructor and make sure it works. When you get it working in Constructor, now I want you to go and build the PLC program for it. And once you get the PLC program built, submit it. Then I want you to draw the diagram of how it's wired in by hand to the outputs and inputs using your sync source knowledge. And they have to do all that for every single lab they turn in. And I'm trying to get them to visualize from a ladder logic to PLC logic. And the reason I'm doing that is I don't know how many times I've had to go out on the floor with my technicians and say, we got to convert this box to PLC and a drive, and you got to get rid of all this motor control stuff. And I need a PLC program written, and they don't know where to even begin. So I pull up the relay ladder sheets and show them how to do it that way. So my guys already know that when they walk in. You give them a picture of a relay ladder diagram, and they'll create a PLC program that'll match that. That's what I'm trying to get them to. So basically in the first course, if you really want to know, we go from basic bit logic, which is an input cutting on an output, up to timers and counters instructions. And basically we're starting at beginner and going into the beginning of the intermediate, which is, counters, timers, doing that. And it's all done with bit logic, okay? I haven't gone any further than that. When I start my second course in the PLC, the more advanced course, we go from the start with the math functions and instructions all the way through to sequence control instructions. If I read the state correction, they touch on it, but they don't really ask to be programming in it. They just mention it a little bit. I take them all the way through. The one thing I will not teach, and I don't teach, is motion instruction, because I don't think too many of them are going to see that until later on down the road. And their companies are going to work with them to learn it. I have no time really, and the cost of buying a motion control, bunch of heavy duty servos and stuff is prohibitive for me to even do that. I know you can get the micro ones, but unless you buy a drive for all those and program and send information to the drive, I've set so many of those up, and it's really complicated and that's another course, and I don't have time to teach that in here. But one of the things I do is we do teach the internet communication, and we have a grant going on right now that we're using the Industry 4.0 skills, which a lot of you already know about because we've sent some surveys out, so showed you some CCCs and new specialization we're trying to work on, and we'll talk more about it at the ET Forum. we're actually going to send you guys out a survey coming up in the next couple of weeks, I hope, that will be designed for you guys to look at. That's going to go over internet communication, HMI, and how do I collect the data on that stuff. And I teach my students how to bring in using a human machine interface, or a touch panel, in other words, HMI. They learn to program that the second semester, set up Ethernet communication using IP Ethernet. Matter of fact, I have someone from the, I guess the ASIT side, or computer science side, comes in and shows my guys how to actually create a Ethernet cable, how to put it together. And then we go back and I cut some lines and say, now build me a cable. I damage a couple of new ones, say, I need a new cable on this, to make them do it. And then they communicate with that cable. That belongs to them now. And they use that to communicate through all their PLC work. So that's kind of how we set it up and do it. Sounds like a lot going on, but if you spread it out over 12 or 16 weeks, you can get it all done. Not too bad. Matter of fact, in the second level PLC, I actually have a little time at the end. So what I did is I do a capstone course in each one of these courses. It'd be something like a Christmas light display, or maybe doing a washing machine off of the Easy Veep, which I'll show you. And in the second one, I make them do the same project they did in the first, but now they have to use sequence control. So what's going to happen is they're going to go in and do, I don't know, 60 or 100 lines of code for all that bit logic, and come in and do it in 5 lines with the sequence control or something. It's really ridiculous. It takes them about 10, 20 minutes to do, where it took them, 20 hours on the other one to do. And they realize the importance of the higher level programming skills. And one of the big ones I do, which when we go into Logix Pro here, I'll show you, is the traffic light. I'm working with a group now that we're training on through one of the grants, and they're doing the traffic light with bit logic. Now we're going to do it with sequence control, and they went from 20 lines, 30 lines of code. They could do it in 1 line, and they're going to be shocked when they see that. That's going to be interesting. So I always get this aha moment in the classes. It's great. And then depending on what you do, I'm not telling you what to buy or do. I'm just going to make some recommendations. It's your preference on books and stuff you want to use. And if you have someone that really works well with your curriculum, do it. For me, I like the Max Raby book. It's a Goodhart Wilcox product. He has a book and a lab manual, and it is really good. And he goes up to some 5,000, and I do teach 5,000 in mine. I just duplicate the 500 labs in 5,000 so they can see the differences directly. And then one of the better series I was looking to switch to before I went to Amatrol was there's a whole series of books by a guy named Frank Petrozzella, who's actually from McGraw-Hill, has it. And they're very inexpensive. I was surprised at the cost on these, but he goes from basic electrical to motors and controls all the way to PLCs, including 5,000. And he has lab books for all of that. And I thought, dang, man, that's a great series to go. And I've talked to him on the phone and helped him build some of his stuff. I asked for no credit on it. I just reviewed and gave him some tips that I would like to see in this. And same with the Max Raby book. I was on the committee for the review of the Max Raby book, and I told them where they made some mistakes, and they did it. And as you guys know, if you've ever had a manual, you've got non-technical people trying to write technical information in these books, and they make mistakes left and right. And I did that with Max Raby on BitShift, and this is all wrong. And I showed them what the problem was, and at the committee, and there's other people like me on there going like, you're right, that is wrong. I gave them the whole scenario to put in the book. All they had to do is copy and paste it in, and they still got it wrong. I didn't do it again. That's the kind of things that you have to take a look at with these books and stuff. We used Amatrol because I do have an Amatrol trainer, for the RS5000, the 990 trainer, and it has troubleshooting and all that, and I love that. So I use the Amatrol, but I lecture from my notes and stuff. I don't use theirs as a lecture, but I make the students go through it. They have to go through the Amatrol modules online, but I do a physical, oops, sorry, I didn't mean a physical lecture. Here's what the software that I use. You know, I use the 500, which is the Micrologix light version. And then I also use the Studio 5000 software. And this is all off the Rockwell toolkit at the bottom of this list. And I did put the Rockwell link. If you're not on the toolkit, you need to get on the toolkit. The reason you need to get on the toolkit is not to get the software. That's great because you do get 10 cents on the dollar on the software. You just can't take it into a facility and use it. But the price of the product drops drastically. You can get it down to you know, a 30 to 40, sometimes 50% discount on some of the product. That makes it affordable us to buy pieces and put things together. When I use HMI, I'm going to tell you now, I use the Automation Direct Seymour Micros and the EA9 series. The reason I use those, the software for the HMI is free. Okay. You won't get anything free for 5,000, but 500 Logix is free. Now I have free HMI software. I just have to buy the HMI modules, and they're like $400. They're not like, you know, $2,000 for, unless you buy a really large screen. I usually the 6 or 7 inch colors, and those work great. And if they don't have enough room on them, that's where they learn to create multiple screens, and that's what they do. And again, I use the Micrologix 1100 and the L16 ERs for the compact Logix because they're the least expensive and they're powerful. They can do pretty much anything. I will warn you about the 16s though. They don't, it's hard to understand the wiring unless you really read through it. The first one I got, I blew some stuff up because I didn't understand how they were putting their commons and their powers together when I first got one many years ago. So I'm going to tell you now, you need to understand how that wires, and the students need to know how to understand wires because it's not straightforward. Okay. And that's a good thing because they need to learn something different than just basic sync source wiring sometimes. And then I use a lot of simulation software, which I'm going to show you. And there's a couple of them I like, but you don't need to get all this stuff. It's stuff that you can use that's going to help you because instead of being in the lab programming, some of this simulation software, they can go home and program. So you can add more to the course and have them program at home. And when I look at their simulation, all I do is run their simulation. If it works, it's checked off. It's 100% because as some of you who are PLC gurus like me, you know, all of us on this webinar can program a PLC and all be different in how we put it together because we all think slightly different logically. And so I tell everybody, just because it, you know, it doesn't look like the way you would do it, if it works, it works. So don't go changing a program when it works. Don't fix it if it's not broken, so to speak, because they thought a little differently logically than you did, and that's the only difference in your programming. So that was some warnings. So if you want to ask questions, start typing stuff in now while I do the demo. And if there's any questions right now, I haven't looked in the chat, Daniele, but guess I could open it up.
There's a question. You got it? Or do you want me to read?
I think I see it. I didn't know I could even get to it. Okay. So one of the questions is what is the difference between 1,000, 1,100 and suppliers? Okay. First, let's talk about the 1,000. It's obsolete now. They don't make them, but they're still being sold. And you can pick them up on eBay for, you know, well, actually they jumped up because they're not producing them anymore, but you can get them usually for under $100. The difference is the Micrologix was a great tool in its day. It's for small programs and managing a small process. If I just want to measure a temperature or if I just want to start a motor and stop a motor, and that's all I'm doing with it, those things are great. And you can buy them in different sizes, and you may only have 4 or 5 inputs and 3 or 4 outputs. I mean, just to do something simple. But they were serial driven only. And you have to get connected to it to cut it on and put it in run mode. And then when you unplug, you leave it in run when you unplug it so it will run. Because if you turn it into remote program and pull off or go offline without leaving it in run, it will not work until you get online, communicate, turn it on and make it work. The 1100 has a screen on it, and you can turn it on, put it in run mode, take it off, set up your Ethernet, look at your IO, you can monitor, you can do everything off of a little screen on it. It's not the greatest screen in the world because they're not backlit, and it's hard to see stuff on there if you're in a dark area, but those are a lot better. I've got Ethernet communication, I've got serial if I want to do it that way, so I can communicate two ways if I want to, and be able to send information out that I want to do it. And they're a little more powerful because they can do more with the math, and you can actually do some computations with it with a single compute function that will actually let the program go in. They also do the difference between a Micrologix 1000 and 1100. If you want to use floating point, it's not as easy on the one Micrologix. You generally, some of them don't have floating point where you do on the 1100. So the 1100 is a lot more capable. Actually, I think the 1100 come out after the 1200 did, but you know, I think if I remember right, because that's like the newest thing. It was designed to replace the 1000, but give you more capabilities. They're all Allen Bradley. There are other manufacturers out there like Siemens. That was another part of the question. And I will show you some exercises. I will not give you my lab manual I built because I haven't published it yet, but I can show it to you if you want to see it. And I'll show you some exercises that we do that are not in my lab. I put them in my lab manual right off of the simulation software. But generally, I'm going to have them wire up to a couple of switches. And I have a board in my lab that my students actually built. I didn't. They built everything. So they have their own built trainer in there with a 1100 and a ER16 there. They can wire in different configurations. And my motors are little computer fan motors that are not 24. They're 12 volts. So they have to know how to get their voltage dropped using series and parallel circuitry. In other words, they build their own little resistor bank to drop the voltage down and get the correct amps in order to run a fan out of a computer. And to me, that's something they need to know how to do. And so they're actually using their skills as they move forward. So that's kind of what I do. But I will share you what we do, and I'll show you what they are going to do in the lab. So what I'm going to do now is stop the PowerPoint, because if you have questions, now's the time to go ahead and do it. I'm on my screen here, so ignore all my. Okay, let me drop this down, and I got to drop this down, and I just a little picture of my backyard. I don't mean to embarrass anybody here, but all right, let's see what we got here. I'm going to go back over here and show you where this stuff is. So I am going to roll this down so I can see what I'm doing here. So the first thing I want to show you is I talked about the constructor software. And oh, wait, before I do that, yeah. So right here, I'm going to show you, this is the ER18. The 16 looks just like it. It's just doesn't have quite as many inputs and outputs, but this is what the compact Logix I use looks like. And I just wanted to show you what that is, because some people have no idea what that looks like. And I don't know if they have one in here of a 1100, but here's another example of it right here. You can add more modules to this, by the way. It's not limited to this fixed PLC here. It does have the capabilities to go forward. I also have the 24, but this can be modular, and you can add a lot more on there. So I have like one of these plus a bunch of stuff. I bought this to replace the one in my trainer. When I bought my trainer from Amatrol, it had an old L23, and the software doesn't even recognize it anymore because it's been discontinued. So the Studio 5000 will not work with that. I have to go back to the old Logix Pro 5000 software, which I have a copy of, and I guard it with my life. So that one I can still program that one, but I'm looking at switching the two out. Because now they come in with the L32 is actually what they're using now in the trainers, which is a lot better than the 24, but it's what I got. So here's the constructor software. The constructor software is a simulated software that does motors and controls. So let me pull one up here. Hang on. Come on, mouse. Get to work in here. This is what it actually looks like. Oh, come on. All right, I'll pull it up. Let me get this background down here. You can see it. This is what it looks like. This is something I make them do. And what it is, and this is an old version. This is version 9, which is I had with one of the Petrozelli books I had purchased a long time ago, and I'd put on my computer, and I never took it off. We're using version 15 now, which actually has troubleshooting in it. So if you're not lucky enough to have the Amatrol trainer with the troubleshooting, you can actually do it here on this. And this gives you a list of things. It's a very small list. Everything you need to do the course, though, is right here. The 15 version is a lot better, which I got to get my new copy. Otherwise, I'd show it to you. Mine expired, so I couldn't pull it up. But it gives you all the symbology for like a normally open switch, closed switches, limit switches, float switches, anything you want to do, temperature switches, basic, normally open push buttons, things like that. It gives you even the momentary ones as well, where you push and it springs back. These will lock in place. And then these are actually auxiliaries, I think. So they actually fit with this. So you have a, make break type push button you can create. HOA, hand on automatic if you want, switches, lights. I mean, coils, motors. When we do my wiring diagram, I can do a motor with it, things like that. I don't know if I have one available here. Let's see if I've got one here. So here's one of the labs we did in the motors and controls. This is a switch. I'm going to change the view where you can actually see this. And notice I have the wire numbers in there. I make them put the wire numbers in. I just admitted Max back in. I think he got knocked off. I make them do the wiring numbers so they can see what they're doing here, and just to allow them to play around with it. The new software will automatically do it for them, but I make them do it manually because I want it done a certain way. So that's kind of how I've got these set up. This is one of the labs. I do a description of this that, with stop engage, switch 1 will turn on the motor. And then once the limit switch is hit, the motor will stop and the red light will come on. And I give them this diagram, and they have to come in here and build it. So I took a picture of this, put it in the lab, and then they have to come in and build this in Constructor so they learn how to build their relay ladder. Then they're going to take this relay ladder. Now I've got to build a PLC program off this. And then they submit to me this diagram that they created, this file, the PLC file for the programming file. And then they give me a IO diagram, hand drawn or using Word, because I put it in Word. So they can use it in Word and physically draw the lines to that. And that's what this software does for you. And then they have to test this too. I want to make sure they test it so they know that this thing works. And so I don't know if I put a sound on it or if you can hear it, but I got a switch. You see the red lines coming in. The motor is now running because it's red and it's going back to neutral. And then if they hit the limit switch for over travel or whatever it is, it cuts the motor, cuts the light on, etc. That kind of thing there. Now, I did not make this an e-stop, which I tell them this should be an e-stop because I did a momentary instead of a locking one. Just because and they'll put in the locking one in there, but this one I had drawn a long time ago. I was playing around with it, showing them. So this particular one has the momentary instead of the locking open one. So, it's just little things like that I try to show them and do in there. So this is really nice. What I did is this is actually in the bookstore, if you want to know. Runs about, I don't know, I think the problem with our bookstore is they mark it up 30% when they get it. And I don't know if they're getting much of a discount, but they do have, I think it's around 40 or $50 or something like that, $60 maybe to buy the software. and they use it for 2 courses. And then the following semester, I don't have them submit it, but I still use it to draw a couple of circuits for them to show them a couple of things that they would have to do if they weren't using a PLC programming. So we kind of use it for a year, really. I mean, if you think about it. And so it's a good price for a year's worth of supply. They have to, it's only for 1 year, good for 1 year. And it's in the bookstore. So that's where I put it, that one in. Now the Micro 850, I have a question. Do you use the Micro 850? Yeah, it's great. The reason I like the Micro 850 is I have a handful of students who come through that are, and I have a Siemens as well. So, but their focus is Siemens. And if you have never programmed on the Micro 850, I want to call it a combination of 5000 and Siemens, because in Siemens, in Al Bradley, you know, your inputs are I's, your outputs are O's. And the problem is everybody confuses an O with a 0. And so that's what it is. And so what Siemens did was they used the output as a Q. And guess what? In micro series, they're Qs. And they program just like a Siemens would program. I'm shocked at that. But it worked out good. They still use tag base, but they actually have the timers and counters work like a Siemens. So if you want a combination of those two, that's a great way to do it. And it's becoming prevalent out there. It's doing out there. So I expose my students to it, but not everybody gets involved with it. But it's their choice. I know my high school uses the Micro. I got them hooked on it, and they use it. So when they come in from the high school, I let them use the Micro to program with, by the way. All right, so I need to get moving because we're almost out of time. I want Marilyn to have a little time to talk to. So any rate, let me see what we got here. Here is the Micro Lite. And the only reason I'm showing you this is that when you open it up, oh no, I'm sorry, I got the full version. I apologize. I forgot, I thought I had the Micro on this one, but I've got my full version going. Let me get down here to the, right here. On the Micro Lite, all you're going to see is a 1000, this 1000, this 1000, and the 1100 Series B, and then just a generic 1100, which is the A. So you're only going to see these few on the Micro Lite. I can't open that up because they won't. I get a conflict if I have both running simultaneously. So those would be the only things you would see in the Micro Lite, but it's free. You get it from the Rockwell software. So let me just drop down here and pull that back up. And so if you go out to Rockwell, you got to sign in. I'm signed in. And the way you get there, once you sign up for it, and you will get the toolkit. It's free to sign up for Rockwell. You don't have to pay anything to sign in or anything. Your students can even do this if they want to get some information, but generally they need to use their student email, because if you're a company, they want to sell you all kinds of product and stuff. So I hit support, and then I go to my downloads. Takes you over here to the download center, and then I generally go into drivers and firmware because it's simple. But you can go to the downloads, and this is where you manage your activations and stuff if you get some software purchased. And you can go here, and then it'll tell you, oh, you got to download the activation manager, which I already have, and all that fun stuff. So I've already done that and got that together. But if you go to support downloads, it's a little easier to get to quickly. Come on. It's just moving like pond water, I guess, because I got the thing open. Whoops. Get back up. I'm moving a little fast here. All right, click. And you can just type in what you want. And so if I want to do Micro Lite. Here, if I just did the RSLogix 500, here it is. Oh, and MicroLogix. Well, it does the MicroLogix, but I think there was a free software section somewhere where you can get it. And remember, the other thing you have to have, and there's a free one on this one, and it's called RS Links. This classic links right here, if you click on it, it's free. Doesn't matter if you click on either one of these, it comes up the same thing. Latest, greatest is this. This is working really well. I'm surprised. Some of these down here I had a lot of trouble with, but This one, it looks like it's easy to get downloaded on a student's laptop. You got to have that for communication. And I teach the students that Rockwell has both software and communication software, two separate software packages you have to have in order to communicate. Where you look at Siemens, it's one package, but in reality, it's just a combination of two software packages. It's still two software packages, just buying one big thing that has both packages together in it. So all of them are like that. You only get one thing, but it's got the software package in there as well. So when you do and you go to click on communicate, another package will open up. So everybody's doing two packages. It's just not in one click. You know, you got to do two different software packages with Allen Bradley. Nice thing about the 5000 software is it does automatically connect up, which is really cool. You don't have to go through all this stuff. So here's the my studio breakdown. It takes a minute to open up. Anyway, I'm going to show you another software package we use, which was the Logix Pro. Oh, no, there it is. So I'm going to open a new project. Actually, I had one opened up here. I shouldn't have done that. Should open the one of I had up there for you. But I'm also going to open up the Logix Pro to show you that, because I use this for my home. And by the way, 5000 and 500, you can emulate. You can use them as simulations. I'm going to let you know that because I know I'm going to get a question about that. Yes, you can use that stuff if you need to. So it will emulate. So I did not mean to do that. I'm going to drop this back out over here and just go ahead and open one I've already got open. So what I'm going to tell you is that I've got the program you're going to see in the 5000 is one that, this is the Logix Pro. If you've seen the Allen Bradley opened up, looks exactly like Allen Bradley, except when I close this out, I got simulations in here. And the list of simulations on this is a basic IO simulator where they can practice. I got a push button and I want to start a program. That's what I can do. Start a light rather. I've got a door simulation. The reason I like these, and I'm going to tell you why I like these, there's tricks to programming on this stuff, which the guys who've been going with me through the courses are going to go, oh my God, yeah, I see now. You know, there's all kinds of tricks. And one of these in this one is interlocking with a PLC program. And the other one is using internal bits. Remember, a PLC replaced a bunch of relays. And believe it or not, each PLC on the 500 side has a total of 8,200 internal virtual relays. You don't need a relay. You don't need to wire a relay in for anything. If you think you have to wire a relay in, I can show you how to program it with a PLC not to do that. Save that wiring, make it faster and easier. The other thing too is that the trick to this one is to be able to flag conditions. They're used as flagging conditions. So one of the last one on this one is the door is opening up and you hit the close button. That has to stop the door. Second time you hit the button, it has to now close. And I go through, make them try to figure it out. And they're throwing things across the room and getting upset. I said, okay, let's think about this. Let's walk through it. I don't do it for them. I make them do it. And then they start trying things and doing things. And all of a sudden they start getting it. And then they create a program for that one. This is in the first semester. They're doing this one and this one. The trick to this one is if you count the inputs I've got, and these are 3 inputs here because I got 3 switches. I have a sensor that's 4, 5. That's about all the inputs. Oh, these, no, right here, these 2, 6, 7. And then I said, how many outputs do you have? 1, 2, 3, 4, 5. I said, no, you got 7. Add the outputs into the inputs. They're actually 12 inputs. Not 7, because I have 5 outputs that can become inputs. And they learned that a light can be an input for something else. And they learn that trick so they can get past this without spilling the beans coming out of here, you know. And that's one of the tricks I teach them to do. And that's what this software does. It teaches them programming tricks, which they'll use a lot going on down the line. This is the last one they do in the first semester. They program a traffic light. Then I have actual traffic lights they go over and can make it work for real. And they've got crosswalks and all that, which I do later on. But the first one, I just get them to program a traffic light to work without, any cars coming up and triggering any sensors and stuff. And the trick to this one is learning how to cascade your timers. Okay, that's the trick to this. And again, the software packages out there, and I know we're getting close to being out of time. Hang on, let me see what this says. Yeah, I know I'm running out of time, and I know we have to go because I got a doctor's appointment coming up. But the last one I want to show you, then I'm gonna turn it over to Marilyn. I'm gonna have to physically leave the meeting, but all right, sorry about that. We didn't get quite through. Ernie must have been a little longer winded than I realized. I don't know. You guys have access to this. This is the Easy Veep software. It is free. All you have to do is easyveep.com and you'll take you right there. It's actually a Festo product. And they went out on their own. They got a separate website for it, or you can go onto the Festo and get it as well. The thing you have to do is you have to buy one of these modules. There is a printer serial port on this that connects to the computer. On the other end is port 1 has a standard printer style, old school printer style plug-in with the pins, and then it goes with a bunch of the wires on the end that you tie into a PLC. Your computer is the process. So for example, as soon as it loads up here, this is a tank. This is one of the first ones we do. The second level semester, I use the automated process and the second PLC together because again, I'm overlapping. We're getting into analog on the second level PLC and I get into analog in that. And I do discrete as well on open loop, closed loop type stuff. So this is where they go. And this is free. The modules you buy from Bluegrass, so you have to call Steve Cersone, and they are about $1,000 a piece. I'm going to tell you the prices keep going up on it. I think Festo is very proud of their products, so I'm just letting you know that. Yeah. .net, I'm sorry. Sorry, it's not .com, easyveep.com. I'm sorry, it was easyveep.net. Thank you for that update. I appreciate that. Yeah, we don't want to get any phishing or serious things. It is easyveep.com. I have it pulled up, but I'm not going to have time to show you. And just to show you some of the things on this, they can't do this at home. They have to do it with the Easy Veep module, and I don't think any student's going to buy it. But they got the washing machines when I make them do. I do go over 7-segment display in the second semester. And then we go over bottle sorting and level crossing. And a lot of this I do in the first semester and a few of these in the second semester. I do. I don't do the elevator here or in the Logix Pro because that'll take them 40 hours to get that done. It is a tough one. And it uses some things that I don't really want them to get involved in. But if they want to do it, I will work with them. I like this one because I can set this up in the lab where they can actually do this. So it's really cool. I got a 2-cylinder one, a 3-cylinder one. These are easy to do. Or they just learn how to sequence, and then I make them use the sequence out function when they get to the end of the course to build these. They also have to do a pneumatic robot with that, and there's a series of other things that I purchased that you may not need or want. This is great software. The only problem is, again, as I told you, you got to buy this module, and they are very expensive. So if you have a grant or you have an extra $1,000 they give you off of Perkins, you might buy a couple of these because that spreads it out. But the students would have to do it at your lab. Do not let these go because, man, they won't come back. So you want to keep them in the lab. So if you need an extra lab station, these are great to have a lab station. There's no wiring to anything other than to the PLC from this module. It transfers. If I hit a push button on the module, it will translate to the PLC, and the PLC will cut it on, and it'll run the simulation. It's really cool. You'll like it if you see it. And if you have any of this stuff and have any questions about how to use it or anything, I can Zoom with you, or I can come to you and show you how to use your equipment if you get any of this stuff. So it's not complicated and hard, but I am done. I'm going to stop sharing, hand it back over. We're doing some PLC training for programming. I'm going to let Marilyn discuss that because, guys, I got to go. I got a doctor's appointment in about 30 minutes. So any questions that you need to send me, you can email me directly or give it to Teresa and she'll send them to me and I'll respond back to those if you need to. All right, folks, that's it. This is basic. If you want
Thank you,
more,
Sam.
thank you.
All right, thanks everybody. We'll get more information out to you.